How's it going, everyone? Welcome. I'm Leonardo Gonzalez here again, and today we're going to talk about is the React performance, especially when we need to look at how can we write React components in the most performant possible way by first look at this course, which is taught by Steve Keeney, the head front-end engineer at Temporal, this execution durable platforms, which is pretty much like some sort of orchestration system that covers a specific business use case. So the goal of this video is not only make a quick recap of what we have learned so far, which is the introduction here, followed by the React rendering, and then we're gonna now take a look at the learn section from React here as a way to describe how do we get here, particularly with React, and then how can we now describe the UI, how can we add interactivity to this UI, or aka these React components. And as we scale our applications and we want to now provide more interactivity and more user interface to the user, now how can we managing state in a way that is succinct, maintainable, easy to update those states, have a structure to define your state. How can we now have a state update logic consistent, maintainable, as well as how can we now pass down data to distinct childs with context. So with that, then we now look at how can we now escape the hatches. In other words, that how can we now deal interactivity that happened outside of this functions or this UI. So for example, network operations, DOM manipulations, animations, drag and drop API, which is also important. So first, as a way just to describe the goal of this course, well, is to look at how can we write now performance React component in the most performant way possible. So the specific goal that we're going to see here is that how can we learn, how can we look at, how can we structure our React components in the most performant way when you are creating this React app, as well as how can we now memorize those components as a way to prevent the React holding, as a way to catch them. Also, how can we now load components later on using the lazy, the React 18 component features, all right, of this concurrency component feature, which is, hey, we would like to now defer this particular task. I would like to now use this low priority re-rendering, such as use defer or use transition, and see how now can we build a tool set when we detect this React performance issue. So this introduction was to describe is the reason why we look at the React performance. So first things first, you need to learn React. Why? Because at the end of the day, perhaps you're at the beginning, you are writing your components, all right, so that works well, good. But sometimes other components, they don't get you the most out of it. You can get the most out of this. And then now all of this little technical depths, or all of these things that you are not considering, okay, accumulate until a point that is actually making your app slower. So to prevent that, okay, it is important to look at how this React works, so we can then develop a tool set that allows us to detect or identify this React performance issue, and how can we now come up with the best practice when that happens. So pretty much the value proposition of the React performance, especially the performance, which is something you can apply to your life, is say, all right, you know what, yes, not doing things is faster than doing it. And this is also applied to, for example, priority. Okay, so it's better to not doing a not priority thing instead of doing it. And there's some corollaries to that. It's like, well, doing things later on is better than doing things right now. But the idea here is to, in the case of React components, is like it is better to not doing things rather than doing it. Okay, the TLDR. And see, we're gonna look at what are the different tools as a way to build this tool set that we need to go through that, especially when we're starting to detect is a component there. Okay, yeah, especially when we need to detect some of these performance issues. So first, check that the application is on React is deployed with the production build. Also, now let's take a look at how the hierarchy components and your states are defined. Let's start with them. You can also look at what is the memoizing strategy that was used, if there are any. Okay. When you need to load code, you can use the suspense APIs as a way to now load content when you need it. Okay, and well, if you're in a pickle, how you can use is to use transition for that. But all of these different items here as a way to now, when you have a performance issue, all right, this is now the tool set as a way to diagnose. So pretty much it's like untying a big knot when you are pulling all of these threads, and that's actually quite interesting. Yeah, that's actually quite interesting. So all right, for that we need to look at how now the React rendering works. Okay, despite then looking at the DevTools, which is okay, you have now the components tab, which is relevant for development, and the profiler tab for performance. Okay, but first things first, we need to make a quick recap of this, of the learn section of React. So here we're going to walk through all of these concepts in the most precise possible way, as a way to then now look at the relevant topic of today's video, which is preserving and resetting states, okay, and extracting state logic into a reducer. So then we can also look at passing data deeply with context and scaling up with reducer. All of this is just as a way for ourselves to look at how can we now in the next weekend, which is actually tomorrow, to build is a Trello clone, and I'm going to deploy that on production, right? And from there, yes, we now have a more realistic example. And how can we use, for example, one of the useful API like the drag and drop API? And I think that's something important. Completely. Completely. All right. Cool. So, because React, after all, is this framework, JavaScript framework that allows to describe UIs. So the way how can we do that is by defining is JavaScript functions, which is in turn is JSX function. It returns this JSX. So we look at how can we describe our component, which is a JavaScript function using the arrow function. Okay, how can we import them? How can we export them? All right, Uh, Also, how can now we is define several or define a component that connect the JavaScript aspect to the template, to the DOM using the JSX. Okay, how can we now conditionally render several components using the if? And here on the if is where we're talking about yeah, and here in the conditional rendering is that what we're talking about now is how React detect those outputs, okay, when you return that. Because at the end of the day, they are JSX, which if you come from a object-oriented programming background, you can think that this is a new instance, but in fact, this is not a new instance. This is like a blueprint, a lightweight description of this. So this preserving and resetting the states is something that is something that we're going to talk about that later. But the idea of this conditional rendering is to see that when we are using, or when we are now returning different JSX, okay, blueprints, there's some rules applied to that, especially when managing a state. Let's not to dive deep too much, because we're gonna eventually reach there. So we look at how can we now define components, conditional components, using the if. Also, how can we render list of elements, okay? Yeah. Also, how can we define is rendering list of elements, okay? And what is important for React to have a key of this, because now we use this key as an identifier, pretty much like when you go, if you have a folder with a lot of files there, and if you remove one, and if you didn't keep track of that, if you weren't aware of what is the content in there, it's like, what happened? You know, it's like, I don't know. So another good example of this is when you go to your kitchen and you have all of your silverware. So your little spoons, your forks, knife, soup, fork, and then you, instead of having all of that, you grab all of it and put it into a bucket. You know, it will take time to actually or for example, when someone actually remove or pick up some fork, it's like, how many forks do you have then? So the idea here of the key is that indicate to React, hey, I want you to now keep track of these elements. And because you need to keep track of these elements, a way to do that, the way how React see this component, is with the render tree. So the render tree is now this data structure that comes from the computer science, which is the way of how we organize data. So pretty much like when you have a fridge, okay, and a backpack. So in your fridge, you put all of, for example, all of the things that you want to, all of the salmon, poultry, red meat, okay, or any other, or your ice cream, okay. So you put all of them there, and in your backpack you put is your laptop or tablet or pencils, your mouse, keyboard, okay. So the idea of this data structure is that they now fulfill a particular use case, okay. They're good at what they're doing in that field. So for example, you can put a laptop inside of your fridge, all right? Now it's going to preserve a lot of time, but that's not what it's meant to be. Pretty much like when you put fish in your backpack, it's like, yeah, you can, but again, that's not meant to be. So this tree data structure, what allows is to provide now access time, insertion, deletions, and traversal in the most fastest way. Using is the log n for that. All right. So Because we look at this, and this is now the people behind React, a lot of software engineers, brilliant software engineers. Actually, not only software engineers, but also designers, a lot of people behind that, product managers, okay? They say, all right, so let's going to use this data structure as a way to represent is the render or the component hierarchy, React component hierarchy, and also we're also going to have is the tree dependency. Why is this? If you want to add some logic, reusable logic to each one of those components, all right, you can actually add them, and when you don't need them, you can just remove them. So the idea here is that by having a small tree dependency, you can not only send a JavaScript code to the client, where now it's going to do that the most fastest way. So otherwise, you will end up sending is a huge bundle of or bloated JavaScript code to the clients, making the application slower. And you don't want that. So understand these two concepts. We got is the render tree and the tree dependency as a way to now, all right, how can we add interactivity to our components? So through the event handlers, we can do that. And also when we want to now define a state, okay, or a memory in your components, you use a state as a way to preserve that state. Behind the scenes, the state, I will argue that they're using is a closure as a way to now persist in the state of the lexical scope, of the outer lexical scope. This is a feature that comes from JavaScript. So anytime you return a function in a function, it gives you now these bonus features as a way to now this return function can have access to the outer lexical scope. Okay, so why we use state as a way to now, anytime React evaluate these components, we store that in some place. In this case, use a state. And also we look at how can we now set a state as a way to update that state, all right? And we do that by setting the state inside of our event handlers, okay? So this is part of the course of this, okay? So local variables don't persist between renders, and change local variable won't trigger renders, all right? So because with this state, when you now define this state as a way to set, when you define this state using the use state as a way to perform a rendering, okay, as a way to update the UI here, you can also do this like so. How React know which state to return. You might have noticed that the use state call does not receive any information about which state variable is referred. There is not identified that is passed to use state. So how does it know which of the state variable return? Does it rely on magic like parsing your function? The answer is no. Instead, it enables their consist syntax hooks. Okay, hooks rely on a stable call order on every rendering on the same component. So they have this particular hooks. They use a state hook as a way to now, hey, we're going to have is a order on every render on the same component. This works well in practice because if you follow the rule above, only call hooks at the top of the level, hooks would always be called in the same order. Additionally, a linter plugin catches most mistakes. Internally, React holds an array of state pair for every component. This is now the data structure we're talking. So React holds an array of states pair for every component. Okay, so this state belongs to this component, and another array, this state contains to this component, or all of this state contains to this component, and so on and so forth. So React gives the next state pair and increment the index. So you can read more about this mechanism in React Hook, not magic, just array. And they create that. Okay. Okay. So exactly, this is exactly. So first render is this. So you define is the user state, the last state, alright? Now they have is this arrays, okay, of state and setters, and subsequent renders is this. And on the event handling, what it's doing is to, hey, when you set this, okay, this set is now hold a reference to this array in this position. Pretty interesting. A naive implementation. So states, oh, okay. So exactly, because all that's what it is that, hey, I got this array of states from this component, an array of setter of this component, and when you call this actually have a reference to the state array. So the actually is now updating that. So you can see right now what it's doing behind the scenes. Okay? So in any case, I think this is quite interesting as a way to understand that what happens when you define is a state, okay? And that actually give you is the state and the setter. So they hold that into an array of that. It's a way to have order on which one of them React needs to trigger that or update that. Okay. So, but the thing here is that this is what states allow us. In any time you set a state, okay, so states remember things in your components. So when you trigger an state, if you look at this, use a state variable when a component needs to remember some information between renders, okay? So that's right. So with a state, we can remember things when something happens, or if you need to remember that. State variables are declared using hooks. Use state hooks. Hooks are a special function that start with use. This is a way of how you can define now your hooks. Okay. They let you hooks into React feature like state. Hooks might remind you to import. They need to be colon conditional hooks, including user state. It is only valid at a top level of a component or another hook. And the use state hooks returns a pair value, which is the current state and the setter. All right, so you can have more than one state variable internally. React matches them by their order. So depending of how you add them or you define your state, React will keep track, and we have an order of that. And the state is private to the component. Exactly. So if you render it in two places, each copy gets its own state. Exactly. So this is now complete the gallery here. This is handle more click. After fixing the crash, add the previous. Okay, when you press next on the last sculpture, the code crash. Okay, fix the logic to prevent the crash. You may do this by adding extra logic to the event handler. For example, like this. Okay, so here is when you can add some logic here. By saying, let's going to now add is the index here, and we're going to is check if the index, okay, is less than, I think is 11, sculptor list, okay, like this. No, it's actually this one, okay. So if sculptor list, okay, if the index is greater or equal than the sculptor's list, then what you're gonna do is to say, all right, I want you to now set the index to 0, right? And so we to go back here, and that's exactly what we're doing here. And then we go back to this. Oh, of course, because I didn't put is the length. Script.length. Of course. And then you got it. Sculptor list is dot length. Exactly. Is the index is greater than the sculptor lib does length, set that to 0. That's a way to go back here. But you say, hey, sculptor is undefined. What are we doing here? It's say now here is failing because it says sculptor list index 0. I want to start is from there. Sex index like this. So if the index is greater or equal to the sculptor list dot length, and I think I get in this as it is. That's right, it's an array. Okay, all right, it'll make more sense to actually set that index to 0. Set that. Okay, this one. If the index is this, is less than this one, okay, so update that. Exactly. Otherwise, well, then set the index here to 0, right? So now when we reach to the last one, it say, hey, sculpture list dot length is evaluated here. Sculpture list at the index, all right? Okay. Exactly, is sculpture list dot length. That's right, is rendering is this. So if this index is less than sculpture list, okay, it's going to increment that, blah, 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 blah. But is the index, okay, is less or equal But if the index is equal here, now on the next render, -1, okay, because it reached to that length, but we want to actually is update it on the next one. So this is supposed to work, you know. Why is this? Because we're telling, hey, this is the length, okay. When we reach to the length 12, because the way how now you set your state is on the next render, okay. So we need to go back one state and then update that. So in the next render, you get actually is the proper data as it is. So after fixing the crash, add a previous button that shows the previous sculpture. We can say handle clicks like this. All right. Select the index. You can also add some logic here as a way to say, hey, if the index, in this case, is next, it's going to call is another button to say, so here is previous. Okay, you're gonna handle is the handle click, handle previous. Okay, previous click, and here we say, hey, I want you to now be this as a function expression by saying handle click. We're gonna check if the index is greater than the sculpture list dot length. Okay, so if the index is greater than the sculpture list, or in this case is the index is greater than 0, okay, now we can go back. If the index is 0, so you're gonna set the index to 0, right? Hey, so if the index is less than 0, no, I want you to set this and keep at 0. You can also add some other logic to say, hey, instead of when you reach to the 0, I will allow you to now is to, well, go into the last element. Okay. So what we can do here is to say, well, so if the index is now greater than the sculpture, so if the index is now if we have a negative index, okay, so we prefer to now update that to go to the last element of this structure, of this array, which is a sculpture list, yeah, sculpture list dot length. All right, hey, let's go to that element, right? If not, all right, then set the index, okay, with the current value that you have, that which is the index -1, pretty much like that. Here we need to define this as an arrow function. There you go. And yes, so we are able to now go to what? Oh, because we're calling is the ROM handler. That's what happened. Okay. So if index is less or equal to 0, that's right, then you're gonna go back to the last element. if index is less than 1, exactly, because we need to start it with 1, because on the next render we're gonna now have that updated to 0. So now here the sculptor actually contains the proper value. So React is going to evaluate that properly. It says sculptor is undefined. If the index is less or equal, exactly, less or equal set sculptor less minus 1. Oh, exactly, because it doesn't give us exactly. Exactly. So now here we're saying, hey, because after all the length count is even the element 0, so we're going to put is here the -1 to say, hey, let's go to start from this, okay, or let's go to this position in memory. That's what we're doing. Hey, let's go to this position in memory. So yeah, pretty much is this. But again, the idea of looking at how can we now set our state, when to set our state, for example, fix stock from input, like so. Oh, this is now to actually add some use state. So I'm going to do this. Fix a crash. Here's a small form they're supposed to let the user, when the feedback is submitted, it is supposed to display a thank you message. However, it's crashed with an error saying rendering fewer hooks than expected. Oh, because you can nested this. Because you can nested things like this. Because you can nested things like this. And in fact, you're going to define is all of your hooks here. Okay, you're going to define all of your hooks here. All right. And if that is sent is true, okay, thank you. Otherwise, you're going to return is this. Oh, what? Come on, what do you think you're doing? Okay. And otherwise, you're gonna send is what? Message. Okay. Cons. Now it's crashing. Is this? Okay. Okay. No. It's okay. It's okay. You're crashing. Chill. So you're going to put this state. I'm going to put this state here. Okay. Oh my god. It's like you're having some sort of issue here with this. Yeah, you're having some sort of issue here. That's quite interesting. That's quite interesting. Why you do that? Oh, come on, you're not gonna let me do this? Is this for real? You're not gonna let me do this? Oh my god. Oh shit. Well, anyway, if this is the way how you want to behave, who am I to judge? Who in the look at that. Who am I to judge, bro? Look at that. Oh my God. That's not funny at all. That's not funny at all. That's definitely, anyway, I'm not gonna fight for this. But it's because of this. You send a message, right? And then you trigger this event prevent and set is to true. Sending this, thank you. So what it's doing is just to organize this. The spot here is that we are actually rendering is several elements here. So we were defining is a state inside of condition. No. And remove unnecessary state here. But again, the idea of looking at this component, but it's, I think this is, okay. So the idea of looking at how now you can is define a state here as a way to say, hey, this what allows is to remember things, okay? So when we trigger enough state update on the next render, we can also look at what we render, what the new UI state. So how does it work? Well, React has now the trigger render and commit phase as a way to first detect who state trigger that, whether it is on the initial render or it can be at the component level, okay, or any of the ancestor components that can trigger that render. The rendering is no more than React calling this component. So when React calls this component, which can be at the initial render, when they create or the root render, I think is the name of the function, root render, okay, it is going to now render this. In other words, it's going to call all of these React components, or in the case of a re-render, which is React will call the component whose states update trigger that state change, and then the output is going to run that function, and the output, which is a JSX, it will take a look at this and say, hey, do we have now more React components? If it is, I'm going to call those React components and check the JSX output and ask the same question over and over and over in a recursive way. So understanding this is now crucial, because not only that, but also React is taking, okay, it's because at this phase React is taking now the inputs for that, hey, to see if this state change actually call. So you can imagine here, the more components you have, or the more bigger your render tree is, as a way to render all of these components, which is when you call all of these components, this can cause some performance issues. But that is something that we're going to talk about later, not right now, okay? Yep. So the next phase is say, okay, now React is going to commit those state updates to the DOM, all right? But only apply the necessary DOM updates if the renders, if they're different between renders, if they are different between JSX. Once you apply those changes to the DOM, all right, now the the browser detect those and apply and renders or paints the UI. So once we know how these things work, then we look at how can we now remember this state. How is the process of remember this state? How can we think about is the state as a snapshot? And this snapshot is that anytime you set a state, you tell React to set that state, it update that state, and then give you a new state in the next render. So this state's values updates, or the state values, or the new state values happens is in the next render. All right. So you can think that when you are setting a React, when you're setting a state, React fix that state until the next render. So this is something interesting, because now it also leads us to define ways of how can we is sending several state updates or batching several states. Okay, so we can use performing several state updates in our event handlers. Okay, or which is something that might go. It is particularly use case when you want this to now is work with the current state, and the output of that, once you apply some transformation, okay, I want you to now get that and apply something else. Okay, so this state updates, or this sequence of state updates, when you're passing a functions, they're useful, for example, when you are defining some async operations in the middle of your event handler. Does that make sense? So, for example, if you are calling it a trigger, the set timeout, or any network operations or DOM operations, okay, something that you have to wait for it, and for some reason you state trigger a renders, all right? And then after that async operation is done, okay, you want to now update that same state with the previous value. So this is now queuing a series of state. And also, how can we now update our state using objects, using arrays, and how we also need to return is a new state. Why is that? Because the idea of this is because it comes from the functional programming, which is say, if our components are pure, if we define this component in this particular way, so anytime you take an input, you return the same output, okay? So giving an input, we return the same output. We can now is make our components much more easy to catch, because we can fix those data, and if those input does not change, we're always going to now return is the same result, which are easy to catch. Also, these components are easy to run in any JavaScript environment. So whether it's on the browser, on the server, or in worker like it is, okay? This is the way of how now we can make sure that this component can run in any JavaScript environment. And last but not least, it allows us to understand is how we're going to pass our data down, okay? And when we, for example, need to stop the rendering, we can do that in the safely way. So this is the reason why we use is pure state, and how now in the case of updating of state by returning as a new state is something that comes from the object-oriented programming as a way to do not mutate states. Following is the solid principle, okay? Single responsibility, open to extension closing modifications, the list substitution. Hey, the subclass must replace its base class. It must have that ability to replace that base class, as well as the interface segregation. So let's going to have is several interface. Instead of having one gigantic object where everyone can interact, let's going to have now several specific interface that users can consume, so developers or application can consume. And lastly, the inversion dependency. So higher level models must not rely on the higher level models should not rely on the lower level, or we must not import lower level models. There must be an interface to do that, to interact, an abstraction for that. So, okay. So now that we look at how can we update our states as an object, as an array, always return a new state, and how can we make our state update logics maintainable, consist, using immer, okay? Then we look at how can we now then managing states. So by managing a state here, all right, because as our application grows, we need to find a way of how to structure our state, because the vast majority of bugs comes with duplicating or redundant state. So we need to find a way of how can we structure our states, how can we make this, or how to keep the state update logic maintainable and share state between distinct components. So first thing first, we'll look at reacting to input state as a way to first look at how now can we declare UI, okay, or how can we write UIs in a declarative way, and what actually does it mean. Because if you don't use React, especially when you want to add this kind of functionality, well, you can do it in the imperative way, which means that you have to pick that element to say, hey, document get element by ID, and then you get that. Okay, what you want to do with this element. All right, what you, for example, is show or hide them. All right, so display equals to none. Okay, but when you want to do this, when, for example, the user click here, all right, so you have to now define is an event handlers, and then you're going to pass that logic to the event handlers. And what happened when you want now is to create now more scalable application. So for example, you want is to define is the password button for setting up, okay, or to show display a password button, or you want now is, for example, is create a form that contains a password button, or several of forms, okay. Let's say you want to create is a onboarding process. So because that process is very imperative, you have to tell to the browser what to do and how to do that. You have to write all of those statements in JavaScript about how you're going to do that. Maintain that kind of structures can be quite problematic. So the value proposition of React is say, instead of you having to tell how you want to do the things, it will be better to say what you want to do. So pretty much when you're getting into a taxi driver, and here you tell to, when you're getting into a taxi cab, you tell to the driver, hey, turn around here, and then 2 street later, no, turn now to left, and then after that I want you to keep forward for 3 street, and then turn to the right. You are actually telling how to do that. Well, instead of with Uber, we can say, hey, I'm going to put that this is where I want to go. But I want you to take me in the most efficient and effective, quickest way possible. Okay. So, how can we do that? React tells you is this kind of a mental model as a way to think when you're going to create your component, which is, all right, first identify all the different visual states, then determine what triggered those states change, so you can now represent those states in memory using use states, all right, which is the 3-step. Eliminate any non-essential states, all right, any redundant, duplicated, contradictory states. And lastly, all right, so connect the event handler to set the state. And that's exactly is the process of when you're going to create this kind of components. You're going to do this over and over and over and over and over. So the faster you do this, the better off we'll be. So that's one of the reasons why I'm going to, after make a quick recap of this, on Saturday tomorrow, I'm going to create a Trello clone. Okay, I'm going to create a Trello clone as a way to say, okay, this is how can we do this kind of thing. And I think that Trello clone, it'll be a great way of how to show up in my portfolio. Mm. Mm-hmm. And we're gonna deploy that on Vercel, and c'est fini. C'est fini. Okay, so this is now how React tell us to think when it comes to describe these UI components. So pretty much like the UI designer actually does. Okay, and here we are combining is a concepts from the database engineering when it comes to now define the state structure. Concept like normalization. Hey, we want us to get rid of duplicated, or we want us to get rid of duplicated, or we want to get rid of duplicated or redundant data. We don't want any inconsistent data, any contradictory data here. So that's exactly the next step, which is, okay, let's going to give us state structure here. So React give you some principles, like avoid any, group state related, okay? Avoid any contradiction states. So any state that are opposed to them when you have, or that actually introduce this indeterministic behavior, eliminate that. Avoid contradictory state. Avoid redundant state, which is, ask yourself, can I get this data from its props or state, all right, instead of defining as a new state, all right? And the other is avoid duplicate states. So instead of create, for example, let's say you want to keep track is the state or an object in an array, okay? Instead of actually using an object, anytime you have now this particular UI pattern like selection, use IDs instead of the object. Why is that? Because it is hard to maintain them. It is hard to keep sync of this duplicate states. And not to mention, last but not least, is avoid deeply objects or deeply nested objects in your state, because now your update logics is quite lengthy. So that's quite interesting. And that makes a lot of sense. That makes a lot of sense to actually do this kind of exercise. For example, this kind of challenge here. That's a way to say, hey, fix a component that's not updating. Okay? Because it's not updating since as long as the props color change, okay? Wait, what? Exactly. But as if the props color, which is this, because now you pass. So what is if you do this, for example? Come on, if you do this, props the color. Props dot color. So if you do this, you actually are triggering is the proper event. So because you are now adding is a redundant state here, because as a way to actually set this, you need to define is a logic to update the color state, and you don't want that. Again, is redundant state. Can I get this data from its props or from the current state? So in our case, by saying is only this, we can now effectively updating is the state, like the color here. Again, we are removing redundant state. Here, this is an interesting topic here, especially when you are going to handle is when there is an UI selecting pattern. Okay, when there is a UI selecting UI selection UI selection pattern, use ID instead of an object because it is much more easy to keep sync. So in this case, because we want to now show this element here, okay, and anytime, for example, we remove that, it's not updating them properly. So we can take a look at this and say, hey, who is this? Or what is this? It's called package. Okay. Because now this information comes from the packaging list, we can say, hey, packages, all right, is something that we want is to keep track, all right? For example, we can say, hey, well, pack is, let me see if we can actually get that data here. It's from pack, right? Because this only accept, we're gonna accepting here multiple elements, okay? We can say now is, well, when that change handle items here, I would like you to now is, instead of showing this state, so keep tracking of this state, I'll prefer to, after all, because we are setting is the package, okay, as a way to add items, we're actually is updating is the next package here. For example, I handle delete, so on change, handle change delete. All right. So because I want to now is look at that data, okay. For example, here as a package, I can say, hey, which one of them are selected, and give me the length of that, okay, from this data. So we can say, hey, this is now called pack, okay. We don't need to actually evaluate this. For example, like pack, and say, hey, is the items, which is the data, by looking at each one of those elements, and if after all we want is to know how many of them are selected, okay, so we actually keep track of that state inside of our collection, let me actually take a look at the item, okay, and check if the item, okay, if the item is equal to true, please return that and give me is the length of that. Okay, if the item is pack, sorry, if the item is pack, if the item is pack, give me the length of that. So initially it's going to now tell to React to store this items and set items in an array, as well as a total and set total, and then evaluate this. Okay, so it's going to evaluate items and say, hey, what is items? What is item? Oh, items is this, but item is now is the data that it contains the initial items. All right, so then let me actually perform this, the initial time. So anything related to the set, to the pack is no longer needed. Okay, because anytime we handle the item change here. Okay, we're going to emit that event from the packaging list, which is something that I don't have access to that. Okay, it's packaging list. But it say, hey, on change item. Okay, all right, I want you to now on change item handle change item, handle change item, exactly, handle change item here, yep, on handle change item, what it's saying is that, hey, I'm going to return is a new state of that, which means that when you return is a new state, okay, it passes through the trigger, render, and commit phase. All right, so in the render phase, it's actually now is calling this function. All right, and that is calling this function. All right, and if there is a different GSX, all right, you're gonna say, all right, let me now in the commit phase apply the necessary state change or the necessary down update to this component. So the browser, once detect those changes, all right, let me now actually render this. Let me paint this for you. And yeah, that's actually what happened. So we have here, we actually updating that properly. We don't need to actually have, in fact, is a state. We get rid of that redundant state. All right. We also can, instead of having a total here, we say, hey, we can get that data, we can get that information from the items here. So anytime you run that, okay, you say, okay, it's going to say the cons items here, I mean the total, and then give me is the items dot length at that moment. And I can get rid of this the state that we're setting here. So, but again, the whole point of this is to only use a state when there is needed, when you want to now have a memory of this data. Okay, that is the core of this. When you want to have a memory of this data, which is local, all right, makes sense. And then you got it. Pretty cool, right? Pretty cool. Pretty cool. And the other is quite interesting. Fix the disappearing selection like this. Is like, because now we were having this. I think they actually removed exactly. Because now we are actually having is this. Fix the disappearing selection. by saying, hey, when you click here, actually get rid of this state. Why is that? When you're dealing with this UI design pattern, okay, it is important to not use an object, use an ID. So for that, we can say, hey, this will be is the ID, all right, and setting the ID letter. So we can start with null, all right, so that is not selected. And when you select the star or handle star, I think it's this, on hover on toggle, you say handle star. You actually set the state here, generating is a new state from that, which is great. You actually here is now remember or having in memory is this particular state. Okay, the letters here. And here, because you want now to keep track of that, highlighted letter ID, okay, you want to know is, well, you want to know here is that which ID do I am getting from them. In this case, from the letters. You say, hey, letters, which are you emitting? On pointer move, and on click you say on toggle star. Okay, so on toggle star is this. So we can say, hey, handle star on toggle star. Okay, on click, I want now to send is the ID of this. So if I send the ID to this, and then I get the letter ID, and then I set the letter ID on the, when it's going to render this element, okay, I want now to check that, hey, it's highlighted, which is come from the letter. It means that is highlighted, it's going to apply, okay, it's highlighted, it's going to apply some class here. Yes, it is highlighted, okay, but I want you to now check is with this. The letter ID in that position, the letter ID in that position is equal to the highlighter letter. So for example, like this. So by doing this, what you're doing is you keep track or remember is this state, this information. We want, oh, you can say initially 0, that's right. Handle hover. Handle hover. On toggle star, letter ID. You say highlighter. Oh, of course. The, all right. What happened here? Yeah, the highlighter ID, the letter ID, and the highlighter ID is by saying, hey, letter ID, I'm going to get this letter ID from this. But when you now click here on toggle star, okay, on toggle star, which is on toggle star, it pass you the letter.id. Okay, we are handling is the letter ID. Okay, and we're gonna actually use is the highlighted letter ID as it is. So we're storing that as 0. Okay, well, which ID do we have right now here? and handle hover, okay, and on hover, handle hover is doing this. Letter, and we're using is the letter.id. Exactly, but on handle hover, this is on handle, okay, on hover we're sending is that. And on hover, handle hover. Okay. And on hover, handle hover. And here on handle star is when we're going to pass down is this. Okay. Is when we're going to actually pass is the state. That's right. Okay. So yeah, this is a way of how you can now is keep track of or showing is this updating element here. So far so good. And when you go now to more interesting states, okay, as a way to say, hey, for multiple selections, create is a data structure, create is a state that keep track as a data structure using set that only contains unique values. And the reason to do that is because it's much more efficient when you're going to access to the data. So for example, here on the selected ID, you say let's going to define is this memory here to get all of the state selected, all right, as an asset. And when we trigger is the event, for example, is toggle. I want you to now, when we render the list, to check if that actually is on the same ID. All right. If it is, well, I want you to now show you highlight this. Is selected is going to show is a class is selected for that. So, all right. So let's get into this. So we say select ID and selected ID, where now we have, again, all of this is because we have a particular use case. So the selected count, which is 1, but we can say is now selected ID dot size, okay. And then is when you say, okay, when you handle the toggle ID, I want you to now take a look at all of this ID, which is the selected IDs, and if you have that ID in this data structure, all right, great. If you have that ID on the data structure, okay, great, cool. Because now I want you to is remove that. We want this to get rid of this. So selected selected IDs dot next dot delete is a toggle ID. What happened here is that we are mutating is the state, okay. Selected ID, otherwise is exactly, if not, is that selected IDs, and add the toggle ID, okay, the toggle ID. But the idea here is that we actually mutating that thing. We don't want that, especially if we're going to set that new state. So for that, well, we follow is the recommendation of React as a way to set the state with a new state. by saying, hey, next IDs with a new set here, that it will have a reference to the selected ID. Okay, so you can think that this event handler is React pause. So React pause the state value here during this rendering. Okay. So React. So during an event handler here, when setting a state in an event handler, you can think that React is fixing or it fixes the value of the state, of the current state, that'll be ready for the next render. So it's actually fixing the current state, the current value of this state, all right? And now we can actually ask to this. And provide is a new state for that. So selected IDs is a state, and and now here we're going to, instead of actually using this, we're going to now compare that. Okay, hey, do we have now this selected, do we have now this ID in this set, in this hash map? And we're using set because it's much more efficient in terms of access time and for security reasons also. But here we say selected IDs. Okay, selected IDs has is the letter.id. Okay. If it is, all right, good. So now when we click here, what's going on? It will call on the onToggle handle here because we click here on change. It's gonna emit not the ID, okay, which is something that we're capturing here in this event handler on the pattern event handler. We capturing is that by actually passing is a handler function. We capture that here because now we're calling is that function on toggle. Okay, we're calling is that function and passing this, and then we're going to create is our IDs and see, hey, is this ID that we get exists? If not, all right, then set the ID for that, which means that it will now say when it render this, okay, now the select ID on the next render, okay, on the next render is when you now going to have is yeah, because so here is set is fixing. So see, here is React. So here React fix the state here. Okay. Yeah. Here React fix the state here. Okay. That's right. So here React fix the state here by saying, hey, because now we're triggering is this event, okay, when I pass in the render phase, which is now I'm going to call this, okay, when I'm going to call this, now the snapshot, which is something that you have here, oh my god, I think it delete, anyway, so now the snapshot here, by setting its state triggers a re-render, and when and how state updates like this, rendering takes a snapshot in time. Rendering means that React is calling your components, which is a function the GSX you return from that function is like a snapshot of the UI. Its props, event handlers, and local variables were all calculated using its state at the time of the render. So when you trigger this, they will calculate it at the time. They were calculated using its state at the time of the render. So at the time of the render. So you click here, you notify to React to update the state, and then it gives you React pass a snapshot of the state value into the component. So React passes a snapshot of the state's value into the component. So setting states only change in the next render. Okay? Like that. So setting states only change in the next render. So by setting the state only change in the next render. And state over time. A state variable never change within a render. A state variable never change within a render. So which means that this will never, so React keep the state values fixed within one's render event handlers. So because React keep the state handlers here, I'm choosing the state structure here, because React is now keeping, in fact, let me actually do this, state as a snapshot, because render take a snapshot in time. Rendering, which means that your component is being called, okay? So rendering is React calling your components. That's right. So it means that React is calling your component, which is a function. Exactly. The GSX you return from that function is like a snapshot of the UI in time. It is props, event handlers, and local variables were calculated using its state at the time of the render. It was using, they were calculated at the time when they were rendering. Unlike at the time when they were called. Okay. So props, event handlers, and local variables were all calculated using its state at the time of render. Why you don't get it? Time of render. So because it triggered an event, okay, now it is time to render, where now React is calling all of these components, is in there, what is calculating is, okay, the props, the event handler, and local variables, using it as a state at the time of render. Using it as a state at the time of render, which is using it as a state at the time of render. Okay, that's quite interesting. Totally. Yep, that is quite interesting at the time of the rendering. Size here. Okay. Yep, at the time of the rendering. So at the time of the rendering, by creating a new state here, so, next IDs, and here you're gonna filter, you're gonna create a new set here of the selected IDs. Okay, and you're gonna check if the next ID has the the ID as a way to say now, okay, it is time to set the ID or to remove it, to delete in this case, delete the toggle ID. Otherwise is, well, okay, next IDs dot add to the toggle ID. All right, and then you're going to set this new ID. So when you setting is this, okay, so when you setting is this, and then you say selected, exactly, selected IDs. It's going to check if the selected ID has a letter dot ID. Okay, if you don't have, if in your records you don't have anyone, it's like, okay, don't show them. But the funny thing is that when you trigger an state update during a handler, when you trigger an state update during an event handler, okay, what's happening is that it's not only trigger a render, okay, but also is calling the component that caused this render. But it's going to call this, but it's going to call this using its state at the time of the render. Unlike a photograph or a movie frame, the UI snapshot you return is interactive. It includes logic like the event handler that specifies what happened in response to input, and React updates the screen to match this snapshot and connects the event handler. As a result, pressing a button will trigger the click handler from your JSX. So when React re-renders a component, React calls your function again. Exactly. When React re-renders a component, React calls your function again. Your function return is a new JSX snapshot, and React then update the screen to match the snapshot your function return. As a component's memory, state is not like a regular variable that disappears when your function returns. State actually lives in React itself, or on a shelf outside of your function. When React calls your component, it gives you a snapshot of the state for that particular render. Your component must, okay, so when it called the oh my god, so when you trigger a render, okay, you're not only passing is the proper state of that render, you're not only passing is the state, but when you're going to call that on the rendering phase, it's going to evaluate the JavaScript with the state that you passed there. With the state that you passed there. So when you click here, it not only add this one element here, okay, so you trigger an event, all right, with this new state, and then with this new state is going to evaluate this JavaScript function, say, hey, the select ID, what it is? Oh, it now has this one. It's going to evaluate all of this, all right, and then you're going to return a JSX that actually evaluate the select ID dot hash the letter dot ID. Okay. So it evaluates this, and if these snapshots are different, if they're different between the snapshot, which is in this case, of course, it has. All right, then it's going to apply the necessary DOM updates to that. So in this case, is now when it renders the JSX, okay, like the letter, it's gonna call this React component again, okay, and evaluate this to return or to call this letter component as a way to return this JSX. Okay. Yep, as a way to return this JSX. Okay. And if there is no more React component, you say, okay, now that I got I'm going to apply all the necessary change to the DOM. The question is that when you set the state, it happens on the next render, like this. So setting state only. So setting state only change. It is for the next render. Okay, for the next render. And for the next render is that when setting states only change it for the next render, because this is when you trigger. Because this is when you React trigger an event and the state change. Now run your state with run your React component with this state that you provide. Okay. And then going to call all of these React components recursively until there is no more, and apply the necessary change on the commit phase to and apply the necessary commit change to the DOM. So the DOM detects those changes and the browser paints them. So the browser detects those DOM updates and then repaints them. So this is the mechanism here. I'm gonna click here. You're gonna evaluate that handlers. You send the state, and when you, oh my God, shit, nigga, fucking shit, nigga, oh my freaking toast that. Okay, now it makes sense. Woo! It makes a lot of sense. Okay, it makes a lot of sense because you are now triggering is that state. This is the new state. React say, okay, I detect that, I trigger, this is the trigger phase, and say, okay, let me now render this, let me now call this function here with this state that I was provide. And if you have any React component inside of that component that trigger and state update, I'm gonna call them, which is this. I'm gonna call those functions here. All right. Yeah, I'm gonna call those functions here. Yeah, I'm gonna call those functions here. Jesus freaking Christ! I'm gonna call those functions here. I'm gonna call those functions here, okay? And if they have, and I'm going to evaluate each one of these statements, okay? Hey, selected. What is selected? Come from that. And this selected. Yeah, it come from that. But what is come from this? Is selected. Hey, because I evaluating is this. Okay, I'm going to pass down there. Okay, which contains the letter and the untoggle and is selected. All right. And then, oh my God. And then I'm going to now is render this, evaluate this. Okay. Hey, now check is true for that particular component in the render tree, because here you have now is the entry point as the app, as well as letter, and letter as a sibling. Okay. Yep. And then he say, all right, if this is selected, he hit evaluate and say, no, it's not selected. Okay, this one is selected. No, it's not selected. The first one was selected. Yes. or the last one was selected. Yes. Okay. But it say toggle like, because it's like this. Toggle it like this. And selected like this. And there you got it. Holy moly, bro. Oh my god. This is a mental model. This is a mental model that people here is actually teaching you this. It's that, hey, learn why do we get here, how do we get here, and then you will go, and then you will embrace complexity. Holy moly. All right. Okay. So now I know what's truly happening behind the scenes anytime we are doing this kind of thing. So when you set that, you passing is the state as a snapshot. Okay. React call that components or renders that, evaluate that function with this new state. Okay. And if that component contains more React components, it's going to call them, get the GSX, evaluate if there is more React component, and if it's not, it's gonna do that in a recursive way when there is no more React components, and then apply the necessary DOM updates, pieces, and then apply the necessary DOM updates, okay, as long as the render is that are different. Okay, so in this particular case, it's going only to apply is to that element. It's going to only apply this. It's going to only apply to this element. Hey, I'm going to render this element. I'm going to render this another element. I'm going to render this another element on the commit phase. So the TLDR of this is that when you have this state structure, okay, choosing the state structure is like, well, group related states, avoid redundant states, avoid duplication state, because keeping sync is quite hard. When you have now selection patterns, UI selection patterns, all right, it is better to use IDs rather than the object itself. Okay, keep an ID or index in a state. Keep an ID or an index in the state instead of the object itself, and avoid deeply nested objects. Try to flatten them. So when it comes to now sharing the state between components, which is here, is like, oh, okay. now things start to make a lot of sense. Oh, okay. Yeah, dedicate time. Dedicate time to do that. That we can do. Dedicate time, immerse yourself in the task, pay your mentors. TLDR of this. TLDR of this. just like that. God damn it. Okay, yeah, tomorrow I'm gonna get the trailer park. No, I will. Okay, yeah, states, bro. State, state, and then stay well up. let's keep moving. Oh. El cuarto del éxito. Alright, so now that we know exactly what's going on, especially when we trigger a state update in an event handler that is causing React to rendering, aka to evaluate this function with this state that you pass. Okay. A state variables never change within a render. Okay. Exactly. State variables values never change within a render. Okay. It has this state that you said that even if it is event handler code is asynchronous. Even if the event handler code is asynchronous, inside of the render on click, the value of the number continue to be 0 even after set number 0 was called. Its value was fixed when React took the snapshot of the UI by calling your component. So by calling your component, here's an example of how that makes your event handler less prone to timing mistakes. Below is a form that sends a message with a 5-second delay. Imagine this scenario. When you press the send button sending hello to Alice, before the 5-second delay ends, you change the value to field to Bob. Okay? So it means that a state values never change within a render. So which means that you have this because it fixed this. Okay, it never changed. Exactly. State variables, state variables value or state values never change within a render. Exactly, never change within a render. And then you say React keep the state values fixed within one render's event handlers. Within one render's event handlers. But when you trigger an state updates, you will now pass that state to that. This is setting states only. So setting the state change only in the next render. So setting the states only change. So setting state only change in the next render, which means that when you trigger that, hey, this is the state changed. So with that understanding, and then we look at how can we share between components known as known as lifting state up. And it's one of the most common things you will do writing React code. Okay, lifting state up. Yep. Yeah, this is known as the lifting state up, and it's one of the most common things you will do writing React code. Okay. With a population of about 2 million, Almaty is Almaty, Kazakhstan. Holy, what the F is this? God damn. Kyrgyzstan, Kazakhstan. Damn, son. What a view, bro. They have a wonderful view. It's like, what? That was a very impressive view. It's like, what the F is it? Jesus. Complete tour guide. That's quite interesting. That's very, very interesting. Anyway, here, okay. So yeah, when you want to lift up state or lifting state ups, as a way to say, hey, I want you to know this state, this memory is shared across different components. Okay, so you first remove these states on the child component, all right, then pass the hard-coded data from the common pattern, okay, as a way to see, hey, this actually work as expected, and then you add the state to the common pattern here. And this is the recap. Why is this interesting? Because so far we have looked at the reacting to input states, look at how React now provides this declarative way of writing UIs, pretty much following is the UI designers and the computer science, where you identify the different visual states, you identify the different visual state, determine what triggers those state updates, you represent is the states in memory with use states, and then you eliminate is the redundant or non-essential states and connect the handlers to set the state. All right, so this is the way of how can we write is our React component, okay, in this declarative way. When it comes to organize our states, hey, group them in group state related, avoid redundant states, avoid contradiction states, avoid duplicate states, because keeping in sync is quite hard, and avoid deeply nested objects. And when you encounter a pattern like UI selection, use the index or the ID instead of the object. So when it comes now to sharing states, which is something that you're going to do a lot of the time, so because this is something common, known as lifting state ups here. Sometimes you want the state of two components to always change together. So you want now the memory here, the data, the information, the state, change or always change together. Okay, hey, I want you to now be able to keep track of this state change. So what happened? So to do it, remove state from both of them, move them to their closest common parent, and then pass it down via props. So when you want us to know a particular state change when we want to particular state in different child components change based on one single, okay, or in other words, you want the state of two or more components always change together, okay, as a way to keep track this. Hey, I want you to now change this state for all of these elements. Change together with all of these elements. Okay. To do it, remove states from both of them and then lifting that. So because now we're looking here at sharing state between components as a way to say, hey, especially here, this is known as control and uncontrolled components. Uncontrolled is those that have local states, You see, when you define your configuration, but they are not flexible, where now control components are flexible because they can receive they receive it is props, and their states depend on it is props. They're useful to describe this in terms of capabilities and how they design this. Instead of components capability and way to design this. When it comes to design this component, okay. When it comes to design these components and the capability. So for example, in the context of the drag and drop API, we have now these components, okay? And what is their capability? Well, I want you to know these components be able to be in one column and then on the next column and then on the next column, okay? This is the capability that I want you to expose. And then in terms of design as well, hey, is this component is it going to receive some of its props, or is this component also is okay. 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 And this is now where the concept of single source of truth kicks in. Okay? So for each unique piece of state, you'll choose a component that owns it. This principle is known as having a single source of truth. It doesn't mean that all states live in one place, but that for each piece of state, there's a specific components that hold the piece of information. So instead of duplicating shared state between components, live up to their common shared parents and pass it down to the children that need it. So your app will change as you work on it, and it is common that you will move state down and back up while you're still figuring out where each piece of the state live, and this is part of the process. To see what this feels in practice with a few more components, think in React. Thinking in React. Oh, but here is as a way to actually how you can pass down that data. Building the static version of React. Product category, product rows, product table, okay, and the search bar. And here in this filterable product, you're gonna have is this. Now in your entry point, which is filterable product table, you're gonna pass the product. Exactly. Filterable table now have this search bar and the product like that. So then you are passing down is the product. This is known as prop drillings. So the product tables, okay, you receive now this, okay. Then you going to iterate through all of this as a way to show is in by the properly with the product category here. But this is known as props drilling, and it's quite actually hard because keep track of how this data flow works is the reason why we have this Redux. Is the reason why we have Redux. So at this point, you should not be using any state, and that's for the next step. Step 3, find the minimal but complete representation of the UI. Find the minimal but complete representation of the UI. So don't repeat yourself. Figuring out the absolute minimal representation of the state your application needs to compute everything on demand. For example, if you're building a shopping list, you can store the items here. Exactly. Now think on all the piece data in this example application. The original list of product, the search text the user has entered, the value of the checkbox, the filtering list of product. Okay, which of these state identify the ones that are not? Does it remain unchanged over time? If so, it is in the state. if it is passing from it is passing from a parent via props. If so, it is in a state. Can you compute it based on the existing state of props in your component? If so, it definitely is in the state. So what left is a probably state. Let's go through them one by one again. The original list of product is passed in as props, so it's not a state. That's right. The search text seems to be state since it is changed over time and can be computed from anything. The value of the checkbox seems to be state since it changes over time and can be computed from anything. The filtering list of products is in state because it can be computed. This is known as computed properties. Hey, this can be calculated, this can be computed. Alright, by taking the original list of products and filtering it according to the search text and values to the checkbox. This means only the search text and the value of the checkbox are states. Nicely done. Props versus states. Props are like arguments you pass. State is like a component's memory. Props are like arguments you pass. Passing props here, like that. Passing props to a component. It's like the passing props to a child, like so. Forwarding props with JSXPrep syntax. With restraint, which is the card children how props change over time. Exactly. Props are immutable. A term from computer science means unchangeable. So when a component, exactly, they are immutable. So, yes. Step 4, identify where your state should live. Okay. Start with the mockup. Break the UI into a components hierarchy. Exactly. Step 2, build a static version in React. Exactly. Build a static version in React like this. Find the minimal but complete representation of the UI. Build a static version in React. Totally. Find the minimal but complete representation of the UI. Now think of all the pieces of the data in this example application. The original list of products, the search text that the user has entered, the value of the checkbox, the filtering list product. Which of these states identify the ones that are not? Does it remain unchanged over time? If so, it is in state. It is passed in front of a parent via props. If so it's in state. Exactly. Does it remain unchanged over time? Exactly. Which of these are state? Identify that are not. Identify the ones that are not. Does it remain unchanged over time? It's not a state. It is passed from a parent. It's not in a state. Can you compute it based on your existing state or props? If so, it definitely is in a state. What's left is probably a state. Let's go through them one by one again. The original list of product is passed as props, so it is not in a state. So the search text the user has entered, the search text user has entered. The search text seems to be state since it changed over time. and can be computed from anything. So in the case of the creating the Trello, it's actually something like that. The value of the checkbox seems to be a state since it changed over time and can be computed from anything. The filtered list of products is in a state because it can be computed by taking the original list of products and filtering accordingly to the search text and value of the checkbox. This only means that the search text and value of the checkbox are states nicely done. Interesting. Find the minimal but complete representation of the UI. To make the UI interactive, you need to let the user change the underlying data model. You will use state for this. Think of state as the minimal set of changing data that your app needs to remember. The most important that your app needs to remember. So my app needs to remember is the order of all of. So my app needs to remember is the ordering of all of these cards, especially if we're gonna create a clone, a Trello clone. You need to remember all of the order of this Trello card. Okay, they need to remember that. They need to remember that. Okay. Figuring out the absolute minimal representation of the state your application needs and compute everything else on demand. For example, if you're building a shopping list, you can store the items as an array in state. Exactly. If you want to also display the number of items in the list, you don't store the number of the items as another state value. Exactly. Instead, read the length of your array. Now think all of this piece of data in this example. The question is that how are you going to actually now okay. So things starting to slowly make sense. It's like the way I'm going to create this Trello clone, okay, is by making start with a mockup, okay, start with a mockup, like this. Okay, we're actually going to follow is this. Start with a mockup, okay, break out the UI components hierarchy, okay, in our case the Trello clone, then build the static version in React. Hey, all of this version is going to pass down here. Then find the minimal but complete representation of UI state. Okay, hey, what do I need to remember? What do I need to keep track? What do I need to remember here? Okay, so for example, in our case, I need to find a way, especially we are now having all of this card, I need to find a way to store is all of the reference of this car per column. Okay, so when I pick up from one and then pass to another, somehow now I can just remove this element from the column one and add them to the next one, or to the to do and the finish and the kind of thing. That's okay. Question: how do you do that? You know, how do you do that? How do you do that? God damn. It's like that. Find the minimal but complete representation of UI state. Exactly. And then identify where your state should live. After identifying your app minimal state data, you need to identify which component is responsible for changing its state. Okay? Okay, which components are responsible for changing its state? In the case, it must be the column if you're going to implement this. Why is that? Why do you think that? Well, because if we're going to add elements to this array, okay, if we're going to add elements to this array, I need to somehow have a state, a memory that actually keep track of all of those elements or all of those cars inside of our column. That makes a lot of sense. Okay, okay. So somehow, we need to actually have a. Oh my God, we need to actually have. Damn, some. Them is like, drag and drop API in MDM. In browsing feature, the user may select draggable elements with a mouse, drag those elements to a droppable element, and drop them by releasing the mouse button. A translucent representation of the draggable element follows the pointer during the drag operation. But you got is the draggable element, the droppable element, the droppable area. Okay. You can customize which elements can become draggable, and the type of the feedback of the draggable element produced, and the droppable element for that. Identify what is draggable. HTML drag and drop uses a DOM event model and drag events inherited from mouse events. A typical drag operation begins when the user selects the draggable elements, continue when the user drags the elements to a droppable element, and then end when the user releases the drag element. During drag operations, several event types are fired, and some events might fire many times, such as drag and drag over. Each drag event type has an associated event handler. Drag star handler. Transfer this. Define the drag's data. Define the drag image. Define the drop effect. Handle the drop effect. Okay. This is now the interface that you can work with. And the example, copying and moving elements with data transfer instance. Firefox only, all browsers. A parking project using a drag and drop. Okay, ambulance. Show vehicle that can park. Okay. Identify where your state should live. Remember, React uses one-way data flow, passing down the component hierarchy from parent to child. It may not be immediately clear which components should own what state. This can be challenging if you're new to this concept, but you can figure it out by following the steps. For each piece of state in your application, identify every component that renders something based on that state. Find the closest common parent components okay, a component above them all in the hierarchy, decide where the state should live. Once you can put the state directly into the common parent, you can also put the state into some components above the common parent. If you can find a component where it makes sense, and then let's run through our strategy for them. Identify component that use state. Find the component parents and decide where the state live. This is known as lifting state up. Okay. Yeah, this is known as lifting states up. Where to go from here? In all the syntax. But here we are looking is at this. Preserving and resetting state. Okay, so yesterday we looked at this, right? Preserving and resetting in state. Okay. And then extracting state logic into a reducer. Something that we're gonna see that tomorrow. Yeah. Because that'll be all for this video. Take care. Bye-bye.